Hey guys, it's me, Miss Yaley. I am going to be walking you through the 11.06 notes. This will kind of build on what we did with 11.05. Just so you know, the 11.06 practice will be due next week. When you turn that in, you do have to only turn in the practice. You don't have to turn in these notes filled out. Obviously, it helps to fill them out just so you know what you're doing. But as long as you have the practice page, that's fine. Just make sure your name is on the top of that practice page, especially if you're printing it out. Make sure you are printing it, writing your name at the top, and then submitting it with your name on the top of it. So before we get started, we're just going to talk about what we're going to be doing with this page. The formulas are exactly the same as they were on 11.05. Obviously, you won't have to memorize these because you'll be able to use your notes. Next week, we'll start the project, the college and career project, and we'll be using these formulas on that project. So you will need to know what you're doing for that. On 11.06, we're basically going to use the same formulas to solve for time. We will be using these same formulas to solve for the t value. So every single time on this page, that t value is what we will be trying to figure out what it is. We'll be solving for time. And in order to solve for time, you will have to use logs. So to solve for time, you have to use the logs, what we know with logs to do this. So it gets a little bit more complicated than 11.05 where you're just basically plugging in numbers and getting the answer. Hopefully you guys have a calculator of some kind. I have a graphing calculator and my TI-36X Pro. So I'm going to be showing you guys kind of with both just so you can see. The 36X Pro is probably the only calculator that I know that can do a log with any base. So it's going to be the best. If you have this, I would highly recommend using it. Your phone calculator or the graphing calculator or the yellow or blue calculators won't have that capability. So I'm going to show you with the graphing calculator because it's going to basically be the one that's not the TI-36X Pro. So when you're solving for time, we're going to start with A over P. And I'll show you basically once we start doing problems, it's going to make a little bit more sense, equals the base raised to your time value. So we're going to get, the first step that I'm going to do is getting each of these problems into this form, into that form. Once it's in that form, we're going to rewrite it as a log. So I'm going to rewrite from this to our log form. And it's kind of been a while since we've done this, but we're going to use log. The base goes in the basement. So that base goes in the basement of A over P equals T. And what happens when you rewrite it in log form is that the T gets to go by itself. And essentially that's what we're trying to get to happen. We want the time to be by itself. The only way to do that is by rewriting this in log form. So the only way to do that is to rewrite in log form. So we go from this form into that form, and we'll show that with some of these examples as well. So formulas are the same. You have to figure out which formula you want to use first, figure out the variables, and then we'll show you how to solve that. So, all right, Disha inherited a sapphire ring purchased for $500. The value of the ring has increased by 8% each year. When will Disha's ring be worth $5,000? So now we have to figure out what variables and what formula we're going to use. So her value has increased. So we're going to use our growth formula, which is A equals P 1 plus R raised to the T. So that's the formula we're going to use. A is the ending amount, so it ends at $5,000. The starting amount is $500. T is what we're solving for every single time on this page because it says, when will the ring be worth this? So when we're solving for when or how long will it take, that's when we're going to be solving for time. And then R is the rate, 8%. As a decimal, divide by 100 is 0.08. All right, let's go ahead and plug those into our formula. We have 5,000 equals 500 1 plus 0.08 raised to the t. All right, so the first step is to get from this formula into this right here. A divided by P equals the base raised to time. So what I need to do is I need to divide by 500. So I'm dividing by that P value to get it to this side. And I'm not actually gonna simplify that fraction because I'm gonna use my calculator anyway, so there's no reason for me to have to simplify it. I don't really need to do that. So I get 5,000 over 500 equals, I can simplify this, 1 plus 0.08, but I don't have to. So again, since I'm gonna be using my calculator, I'm not really worried about simplifying anything until I put it in my calculator. So the next step is where this gets a little bit complicated. So I just wrote everything in the formula. I divided by the P to get it to here. Now I want to rewrite this as log. I want to rewrite this into log form. So it will be a log. The base, the part that's being raised to a power, is 1 plus 0.08. And I know that that looks kind of crazy and it looks weird, but again, I'm using my calculator. I don't really care how crazy it looks because I'm going to be able to plug it straight into my calculator. So log base 1 plus 0.08 of 5,000 over 500. And that equals the t value. That equals our time. So once I find this, I'm going to be able to plug this straight in to figure out what my time is. Okay, so this is how you plug it in the calculator. If you have the black TI-36X Pro, this is going to be fairly simple. If you have the black TI-36X Pro, all you need to do is press the log button 3 times. If you hit the log button, which is right under the second, 3 times, you're going to get log with the little base and the argument. So I can just plug this in. 1 plus 0.08. And here I have 5,000 over 500. And like I said, I don't need to simplify anything because I'm just able to plug it in right away. And I can hit enter. And I get 29.92 years. So T equals 29.92. So it's going to basically take her 30 years for that ring to go from $500 to $5,000. It'll take it 30 years. Let's say you didn't have the TI-36X Pro. If you don't have this calculator and you have anything other than that, this is how you're going to need to do this. It's called the change of base formula. It's right here. If I have a base and an argument, this calculator doesn't have the capability to put in the base. So, and this is the same with the yellow calculator and your phone calculator. So I just have a graphing one because that's all I have. But I'm going to show you how to do this. So I need to do log of the argument divided by log of the base. So I have log of the argument, log of 5,000 divided by 500, divided by log of the base. Where's the log button? Log of the base, which is 1 plus 0.08. This is kind of like, it looks a little bit more complex than it did in the TI-36X Pro. Again, that's like the easiest one. If you don't have that, then you can still do it with your phone calculator or anything else. So hit enter, I get the same exact answer. So even if you don't have the TI-36X Pro, you can still do these problems. If you're doing the phone calculator and you turn it to the side, it also has a log button. You just have to do it in multiple steps. There's also calculators you can find online too. So just because you don't have a calculator, that does not mean that you can't do the worksheet. All right, Jaden deposited $1,000 into a savings account that earns 2% annual interest compounded continuously. How long does it take Jaden to double his money? All right, so some things that are important. Jaden deposited $1,000, so that was the initial amount that he put in the bank. It's compounded continuously, which is our A equals PE raised to the R times T formula. So So it's our PERT formula. 2% interest, which is 0.02. Time is what we're solving for. And then doubling his money, if I start with 1,000 and I double it, I have 2,000. And even if they didn't give us an initial amount, you should still be able to solve the problem. Even if they don't give you an initial amount, you just make it up. So you make up an initial amount, you double it for your ending amount, and that would be it. So even if it doesn't give you a specific value, you can still do the problem. All right, so putting these into my formula, I have 2,000 equals 1,000. E raised to the R, which is 0.02, times T. All right, a few things that are different about this problem, but the first step is exactly the same. So the first step is to divide by 1,000. So I'm essentially getting the exponent part by itself. And I can simplify if I want to, but I'm not going to because I'm just going to use my calculator anyway. I would hate to do this whole problem, and the thing that I messed up on was just trying to easily simplify it. So let the calculator do the work, just leave it. You don't need to simplify it, it's fine. If you do, it's fine too, but I'm not going to worry about it. Times T. All right, so all I did was move that p-value to the other side by dividing it. Now I need to rewrite this in log form. And since it's E as the base, I'm going to need to use a natural log. So E is our natural log, ln. So ln is our log. It does have a base of E. We don't need to write it. I'm going to write it, but I'm going to cross it out. So that's why I'm used to the ln. The argument is 2,000 over 1,000. And that equals 0.02 times the time. 0.02 times the time. And then I'm going to use my calculator. In my TI-36X Pro, now I'm just going to press log one time to get my natural log. ln of 2,000 over 1,000 equals 0.6931, and that equals 0.02 t. So this time I have to go one extra step. I can't just put it in my calculator and get the answer because I'm solving for 0.02 times t. So in order to get t by itself, I need to divide by 0.02. And I don't want to round in my calculator, so instead of typing just the rounded fraction, or rounded decimal, I'm just going to divide this by 0.02, which is 34.66. So it's going to take 34.66 years for this to happen. So basically the steps were plugging it into the formula, figuring out what formula, plugging it in, divide by P, and then rewrite it in log form. All right, let's try this again. Andrew spent $1,200 on a credit card this month. The credit card charges 24.5 annual interest, compounded quarterly. Compounded quarterly, that's important. If Andrew makes no payments, how long will it take until he owes the credit company $2,400? So this is kind of real world. If you start by getting a credit card and then you make a bunch of charges and then you don't pay them off, you're going to be charged a whole bunch of interest on that card. So the more interest you're charged, the more money you're going to end up owing them. So he starts by only owing them $1,200. But eventually he waits so long to pay it off that he now owes $2,400. And this actually doesn't include like late payments or anything else. This is just talking about the interest. So there would be other fees and stuff that go along with that, just know in real life. This is compounded quarterly. That means our n value is 4. Compounded quarterly means I'm going to be using the formula A equals P 1 plus R over N raised to the N times T. So that's the formula that I'm going to be using just based on the fact that it said it was compounded quarterly. So anytime it says compounded and doesn't say continuously, you're going to use that formula. The rate is 24.5%. And notice that that's a lot higher than the other interest that we were talking about with banks and cars and everything. Credit cards really get you with these high interest rates, just making you pay a lot of interest on that. And T is our question mark. That's what we're trying to figure out. All right, so plugging this in, A is 2400, sorry. P is 1200. 1 plus the R, 0.245 over N, which is 4, raised to the 4 times T, which we don't know. The first step is to divide, get P by itself. So I'm going to divide by 1200. 24 divided by 12 is just 2 if you want to simplify it, but I'm just going to leave it. 2400 divided by 1200 equals 1 plus 0.245 over 4. And again, it looks scary, and it kind of is. It's a lot of fractions and decimals and a lot of things to deal with, but if you just take it one step at a time, and use your calculator, it's not really as bad as it seems. So the next step after I divide by P is to rewrite this in log form. So to rewrite this in log form, I have log base. The base is this huge thing, 1 plus 24.5 over 4. So that's my base. The argument is 2400. Over 1200, or just 2. The only reason I keep it like this is because most of the time it's not going to simplify to just a whole number. So I don't want you to have to round, because then your answer becomes a little bit off. And that equals 4 times T. All right, now I'm going to plug this in my calculator. If you have the TI-36X Pro, this is actually not that bad at all to plug into the calculator. I just hit log 3 times, and I plug it all in. So 1 plus my fraction bar, 0.245 over 4. And then the argument is another fraction, 2400 divided by 1200. And that's 11.65. 66 actually, equals 4T. To get T by itself, I'm going to divide by 4. Divide by 4. So T equals, divide by 4, 2.91 years. All right, 2 more. Claire bought a car for $12,000 that will depreciate at a rate of 13% annually. How many years will it take for Claire's car to be worth half of its value? So she buys the car originally for $12,000. It's going to eventually be worth half of the value, so cutting that in half is $6,000 at the end. The rate is 13%. Which is 0.13, and T is what we're solving for. That's what we don't know. So how many years is it going to take solving for T? This is decay. A equals P times 1 minus R raised to the T. All right, plugging it in. A is 6,000 equals 12,000. 1 minus 0.13 raised to the T. First thing I need to do is divide to get that parentheses by itself. Divide by P, divide by P. I can simplify, but again, it's not usually going to end up being a nice, pretty whole number. In this case, it would just be a 1/2 if I simplified, so I'm just going to keep it like that. So I have 600 6,000, sorry, over 12,000 equals 1 minus 0.13 raised to the t. And the next step is for me to rewrite that in log form. Log, the base is 1 minus 0.13. The base is always what's being raised to the exponent. And then the argument, 6,000 over 12,000. And that's going to equal t. So in this case, all I have to do is plug this into my calculator and then I'll get my final answer. So I'll use my graphing calculator this time just so you guys can see, if you don't have the TI-36X Pro, how to do this problem. So in order to do this, if I don't have the TI-36X Pro, I do log of the argument, which is 6,000 divided by 12,000. And then I'm going to divide that by log of the base, in this case 1 minus 0.13. And I get 4.9798. So t equals 4.98. So basically it's going to take 5 years for that car's value to be cut in half. 5 years for it to be cut in half. All right, the last problem is actually going to be the type of problem that you are going to see when you do your project. So I'm going to put a star by it. So this is something that you should come back to. Maybe I'll even write on project. So this is the one that you'll see on the project. If your parents invested $10,000 for you to save for college at 2% interest compounded monthly, how long would it take to cover all of your college costs, assuming it costs $35,000 per year for 4 years? All right, so if they invest initially $10,000, it's compounded monthly. That tells us what formula to use. A equals P 1 plus R over N raised to the N times T. That's the formula that we're going to use. The A value is going to be what it costs to go to college. So to go to college, it's going to cost them $35,000 per year for 4 years. So I need to first figure out how much money that's going to be. 35,000 times 4. So the total amount that it's going to cost for college is $140,000. $140,000. So they basically need to save up from $10,000, $140,000. T is what we're solving for. How long is it going to take for this to happen? Rate is at 2%. As a decimal, it's just 0.02. And N, compounded monthly, is 12. 12 times per year. All right, so putting this all into our formula, $140,000 equals 10,000. 1 plus R 0.02 over N, 12, and 12 times T. The first step is to divide by that P value. Divide by 10,000. And again, when you guys do this on your project, it's not going to be a nice fraction or a nice number when you divide this. So just leave it as the fraction. I know it's kind of weird. It's going to look a little bit more difficult, but just leave it as a fraction because that's what we're going to see. So we have 140,000 divided by 10,000 equals 1 plus 0.0302 over 12. I have 12 times T. All right, the next step is rewriting this in log form. In log form, this is going to be log base 1 plus 0.02 divided by 12. The argument is 140,000 over 10,000. And that's going to equal 12T. All right, so I'm gonna need to put this in my calculator. If you have one of these TI-36X Pros, you can just hit log 3 times. 1 plus the fraction 0.02 over 12 of 140,000 over 10,000. And that is 1584.75, and that equals 12t. And if you guys notice, when I'm doing this in the calculator, I'm not rounding at all. So I'm not gonna round this and use this number in my calculator. I'm just gonna hit divided by 12. So to get t by itself, I'm gonna divide by 12. And I'll get t equals 132.06. So it's gonna take, if they put $10,000 in the bank and they wanna make $140,000, notice that's a huge jump. So that's a lot of money to be earning in interest. It would take them 132 years for that to happen. And when you guys do this on your project, it's going to be an answer that's huge. So I wanted to kind of make it look similar, because I don't want you to think just because it's a huge number that it has to be wrong. It's going to take a long time for $10,000 to turn into 140,000 at an interest rate of 2%. That's just what happens. It just takes a long time for that to happen. All right. So this is your 11.06 notes. Remember, you guys are going to be turning in 11.06 practice. It's due next week. When you turn that in, you only have to turn in the practice page, but make sure your name is written on the top of that paper. So you need to write your name in your handwriting on the top of that paper. The next thing we're going to do is that project. So when you do the project, you might want to be referencing back to questions like number 5 here so you can see what those look like. All right.